Hello, ROS developers, and welcome to another series on developing robots with ROS. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, ROS for autonomous cars, everything ROS is here. Learn ROS step by step and push your ROS learning in just 10 minutes of video. Hi, I'm Arif, and today we are going to answer this question, which is posted on the Constructs forum. But before anything else, remember to visit the Robot Ignite Academy, our online academy where you will find practical online ROS courses using simulated robots. No installation required. You will find a link to the academy on the video description below. Now let's start with this question. This question was posted on our forum by, this is quite a long name, Fares Cabertana. I'll call him Fares, I suppose. Okay, so he's trying to make his own Python code, which will publish to a topic and also to subscribe to another two topics. And somehow, and he's using this Pharaoh robot simulation, but somehow he's getting all zeros. All the values that he is getting from the topics are printed as zeros. Okay, so I'm going to answer this specific question, but really I believe that what I'm going to share is going to be very beneficial, especially for beginners, those who have learned all the basics but now wants to try and write your own codes or your own programs to do anything. Okay, so I believe this is what's happening here. He has learned the basics, is now trying to go into ROS a bit deeper. He's trying to write his own code. Okay, so we'll see how to solve this problem. Okay, so we are going to use, as usual, our ROS Development Studio, ROS DS. So I'm going to start with creating a new project. Let's call it something print um, position. Is that what? Yeah, print position Q&A, QA. Okay, okay. Put some description here. I just copy the same thing as the name. Let's create. Okay, let's open the project. Okay, so as you can see, the code is here, but it is not formatted properly. Okay, this is a Python code. I'm going to copy all this. This is a Python code, but because it has been posted in this forum, all the indentation, some things has been missing, like the hash or the pound symbol is missing there. So we'll have to fix the code a bit. Okay, so this is our new project. So I'm going to start with a shell and also one IDE. Okay, so first thing is to create our package. Let's go to Catkin workspace, source, and then Catkin create package. Let's name it in POS, for example, with the dependency of Frostbite. Okay, it's taking some time to load to actually create. Okay, there you go. So now under Catkin workspace source, I have print POS. Okay, next I will create a new directory called scripts, just to put our code there. Okay, so here, oh sorry, I should have go into the print POS first. Let's just move the scripts folder into print POS. Okay, so it should be like this: print post, scripts, source, list package. Okay, so in scripts, let's create a new file. I'll just put the name as main.py, simple name. Okay, let's open this. Let me maximize the window. Let me enlarge it a bit so that we can see what's actually being written. So I'm going to paste the code which I got from this particular forum, particular post on the forum. Okay, so this is it. Immediately it says on line number 1, it's an invalid syntax because this is supposed to be like the shebang symbol. Okay, and then we are going to go through this. Let's see what else do we need uh, to do some cleanup of the code. So let me just remove the spaces. These are all the imports. That's alright. This is where we initialize our node. Okay, I'm going to leave it as this for the moment. Okay, now there is this def, or this is a function. So anything inside a function has to be indented. Um, I'm not sure which lines is supposed to be inside this function, but I'm going to guess it's until here because this is already another function. So I'm going to select all this, indent them, and just quickly remove the spaces, the blank lines. Okay, I'm going to do the same with this one, IMU function. Indent this. Oops, okay. So there's another function called twist. I suppose it's going to be until here. Let's just do this first. Okay, and while not ROS-by is shut down, should be not within any functions. Okay, so first of all, it's a good practice to not put functions inside the um, main loop or main program. So I'm going to cut the functions, cut it off, and put them way at the top, right after the imports. Okay, so here we import the libraries, and then here are the functions, and then this is our sort of main code, main program. Okay, and then there is this while loop. So everything inside the while loop must be indented as well. Oops, okay. Okay, so this is the basic structure. Okay, it's always good to actually follow the basic structure. Okay, so let's go now. Let's go line by line and see how do we actually do this. How do we initialize a node and then make it publish to a topic and also make it subscribe to some topics. Okay, so here let's start with this line. Prospy.init node Sphero. Okay, this line will initialize the node. It's a good idea. It is not a good idea to name a node with a name that is going to be that is probably going to be the name of something else as well. For example, it is not a good idea to name the node Sphero because Sphero is the name of the robot. So there might be another node for the robot named Sphero already, and when we launch our node here named Sphero, it will kill the first Sphero node. Anyway, so let's change the name. Let's say I'll change the name to Sphero Monitor because we are going to monitor some values from the Sphero robot. Okay. Okay. Next, we are going to say that this node will be a publisher to the topic /command val. of type twist, queue size 1. Alright, this is good. Okay, and the rate, we are setting the rate to be 0.5 Hertz, which will be, which means every 2 seconds. Sorry, exactly, every 2 seconds it will publish to command val. And then we go into this loop while not ROS-PY is shut down. We are creating a variable called move of type twist. Okay, that's good. So move.linear.x is 2. This is actually in meters per second. So 2 meters per second is actually fast, really fast, especially for Sphero. And the angular.z value has a unit of radian per second. Okay, so I'm going to make this slower. I'm going to put say 0.2, which means only 20 cm per second. That's 10 times slower than what's originally put here. But anyway, we can always change this and we can experiment with the values. Okay, so that's the linear x value, that's angular z value, and then we say pub.publish move, publish this, okay, on this particular publisher, which will publish to the topic command val. Alright, that's good, that's correct. So when this goes on, when this loops here, when this is being executed, we will send a message to command val topic. Alright, next, rospy.spin. This is not the right command. We don't use rospy.spin here. Rather, we use rate.sleep. Okay, why? Because rospy.spin is something that we use when we want the node to be alive but not doing anything. Sorry, just alive, not not terminated, just waiting for say a callback or subscribing to some message. But here we are not going to do that because we are in a loop. Yeah, we are in a while loop, so we are going to loop. We are not just going to be at one place waiting. Okay, so we are going to loop. So that's why we sleep instead of prospect.spin. Okay, so that after it sleeps, it will go back up here. It will keep the loop on. Okay, so this should be correct for publishing to command val. Now, how do we subscribe? How do we subscribe to say the odometry message? How do we get the odometry message or the IMU message or even the twist message from the command val itself? Okay, um, so the way to do it is actually to define the subscribers not in the functions but in the main loop itself. So see here, right after saying we are going right after saying we are publishing to command val, we just say we are also subscribing to odom. Okay, and it has to have the slash odom. Okay, and we are also going to subscribe to this one, the IMU values. Okay, how do we know? How do we know this is the topic names? Well, let's start. Let's start the simulation. Turn on Sphero. Okay, while we are waiting for the simulation to launch, let's just go back here. Okay, this is how we are going to mention that we want to subscribe to a particular topic. The way to do it is to say rospy.subscriber, name of the topic, type of the message, and the callback function. Okay, so whenever whenever the node receives a message on this particular topic, it will call up this function, which is this function, and it will start to do all this. That's the way to do it. Okay. Similarly, whenever a message is received on this topic, it will call up this particular function, which is this one. So it will do all this. Okay. Okay. Again, it is not a good idea to have names of functions to be say just odom, because odom is also the name of the topic, so it could be confusing, it could be conflicting. So and plus, because this is a callback function, usually we just put in the word callback there. So odom callback, imu callback. Okay, so similarly over here we have to do to add that word callback, imu callback. Okay, so now we know these are callback functions. All right. I don't know why you would want to also subscribe to the twist message, to the twist to the command val topic, which is of type twist, because we are publishing to it. We are the publisher. We don't need to also subscribe to it. Okay. But if you do want to do this, then go ahead and modify this particular function accordingly. Okay, so let's just go back to our simulation. Is it on? All right. We have the Sphero robot inside this world, gazebo world. So let's go to a terminal and just say ROS topic list. Okay, these are the topics that are available. So yes, we have one command val, and we have odom. We also have Sphero imu data tree. So these are the three topics that we are interested in. Okay, so again, the name of the topic must start with the slash. Okay, so now we have two subscribers. We can't put the same name for them. They have to be different. Okay. Yep, that looks okay. Now let's go into the callback functions. So again, whenever a message is received in this topic, it will call this function. So once it calls odom callback, the message that comes in is in this particular variable, this msg variable. Okay, so we do not need to create another variable of that particular type. We can just use whatever is already inside msg message. Okay, so what that means is, instead of creating another variable of type odometry called go, I can just use msg here, message here, msg.post.position x, msg.post.position y. Similarly here, this is also msg. Okay, so for those who does not know, how do we get this? What is this msg.post.post.position.x? Okay, what we are trying to get here is the x position. Okay, x position of the robot. So if we go back to here, so we are talking about this particular topic, yeah, slash odom. So let's go, let's do ROS topic info odom. Okay, so it says the type, the message type will be nav messages slash odometry. Okay, gazebo will be publishing, no subscribers yet. So we want to see this particular message. Let's type ROS message info nav messages slash odometry. and it will list out. It's quite a long one. So post message info nav messages odometry. We will have a header, um, sequence, timestamp, frame ID, and all this. So we want position X and also position Y. We can also get the orientation X, Y, Z. We can also get the twist. This is actually the velocity, the speed of the robot. Okay, you can get the linear X, angular values as well. So that's why when we write this, how do we get to X? We go, okay, so we go message msg dot post dot another post dot position dot X. Did you see that one? Let me move this a bit. Can't move it. Okay, anyway, there you go. Okay, you see, this is this one. Compare that with this. So msg.post.post.post msg.post.post.position.x. So msg.post.post.position.x. Okay. So similarly, say this one, message.post.post.orientation.x, message dot that's the first post post dot orientation dot x, okay, or dot y. Okay, so that's how we get the actual value. Okay, so this will print out post x equals to the value, and at the end we don't need to sleep. Okay, we do not need to sleep. We can just exit the function. Okay, so similarly IMU callback, we do not need to create another variable. We can just use msg here, message. Sometimes I say msg, sometimes I say message, because I do not want to confuse people with the word message. I hope you get it. Okay, so that should be it. Whenever this callback is being called, okay, whenever this function is being called, it will do this, print veloc angular z equals to, and get the values here. Okay, it says there's some error here. Undefined variable ls. Oh, we've changed that already. Alright, no worries. Okay, so what else? I think that's about it. Let's give it a try then. Save this. Save. And then let's go to the terminal, to the shell, and also the simulation. Okay, first of all, we have to make our Python code or Python file to be executable. So let's go to the particular folder, cd print pos, cd scripts. This is where we have our Python code. So it's always a good idea to actually uh, do this every time we have a new file, new Python file. So just go chmod plus x. Let's see, it's a bit bigger. So chmod plus x, and then the name of the file. So chmod plus x main.py. So this will make the Python file executable. Then only we can do ROS run. Name of the package is printpos, and name of the file is main.py. So hit enter, and okay, there you go. We are getting some values here, and we have our robot moving like crazy. Still quite fast, these values. Okay, so let's just stop this. Control C to stop, to kill. Okay, the robot would not stop because we did not send uh, command val 000. Yeah, we did not so that's why it's still moving. Anyway, there is a topic for another video. Okay, but let's just try this. Let's make this a bit slower. 0.1 meter per second, which means only 10 centimeters per second. That should be okay. 0.5 rad per second. Let's leave this like so. And I would also like to put some dividers. Whenever we print this, let's put something like this so that it's easier to see. Okay, save all that. Go back to the shell and gazebo. So we have lost our robot. It's there. Anyway, if you want to restart gazebo, just click here again. Click on the simulation again. Okay, give it some time to restart. And then we are going to run our main.py again. Okay, almost there. Loading. And there you go. So we have our Sphero. And now I just press enter again. Okay. Alright, so now the robot is moving a bit slower. That's still quite fast to me, but it is moving. It doesn't look so crazy now, and we are getting some values here. So let me stop this and inspect these values. So now we are getting the X position, the Y position. We are getting 0 as the orientation. Okay, we do get some values for the angular z velocity, angular y velocity, as well as the accelerations. Okay, that's good. So yeah, I suppose this answers that particular question on why he is getting all zeros. Okay, so this is how we write our code, um, so that we do get some values, actual values. Okay, just one last thing before you go. Why is this orientation x and y 0? Is there something wrong with our code, or that's how it is? Okay, let's just ROS topic echo again. ROS topic echo odom. Okay, so this is the message that we're getting on odom topic, and we just stop here. And if you inspect the orientation, it is always 0. Position has some values, but the orientation is always 0. Yeah, this is also 0. Up, always 0. So it doesn't mean something is broken. It just means that the robot is not publishing this value. It's not calculating it. So yeah, maybe some other robot does have this value, but not on Sphero. Okay, so I suppose that is all. In the description, you will find all the resources mentioned in this video and the links to them. So if you like the video, please give us a thumbs up and remember to subscribe to our channel and press the bell for a new video every day. Whether you like it or not, please share your thoughts in the and questions. Sorry, please share your thoughts and any questions in the comments area. Peace out.